What's our ideal percent? 6.25. How many people got 6.25? Good, good. Colby, Kate? 6.5?
I had 6. I don't know.
Okay. Well, if you're in that ballpark, you're in the right range. So, Katie, how about you? Did you get that one finished out?
Yeah.
What did you get? 6.5. And Cadence? Didn't finish it? Okay. Did I cover everybody? And I guess, yeah, that's how you had it. Okay. All right, so what was our first step? How did you get the 26p and y? Okay, 0.6 times 10,000 plus 0.4 times 50,000. And what did that get you? 26. Now, mathematically, I saw some of you kind of start off that way, which is kind of natural for me to do too. Let's see if this thing's coming up on screen or not. So we can add that P right into this equation if we're thinking about now instead of the company's profits, which is how we're characterizing it here, if we're thinking about Ron getting a fraction of it. So that's where that P sneaks in. So you can put that P right here and that P right here. So it's 10,000 P and 50,000 P. This is the expected value to Ron's cut. And if you do all that math, we get 26,000 P. And P again is some fraction. If we wanted to be a little more formal, we could say let P be a number between 0 and 1, less than or equal to 1. And P is the fraction of the profits that Ron's going to get. All right, and if he works hard, what does that equation look like? 0.2, good, so he gets 20% chance of getting the 10 now. And he's still going to get the P, plus 0.8 times our $50,000 chunk, so he's got a lot better chance of getting a higher end. And then what's the last little chunk we added on?
$1,000 costs.
Yeah, the $1,000 cost. So we just modeled that there was additional effort that he needed to put that cost him something, and they just had that as a flat 1,000. And so this chunk here with the P's gives us, what was it, 42?
Yeah.
42? 42,000 P. If you math that out, minus 1,000. Okay, so it's important to get the two states of the world straight for starters. I want this to be. Okay, I think it's picking it up. So the question asks, what is the optimal fraction? So I want to make sure we're all 100% on the economic intuition and not just mathematically inclined to set the two equations and solve for P. So what is P exactly in this case? How would you characterize that in kind of economic terms of the two states of the world? It's the percentage that Ron's going to get off of the profit. So it's a fraction of the profit, but we're solving for P. You know, what's going on with this problem? Jesse? You're just stretching? Oh, maybe I'll just call on you. What do you think? Because you got the right answer, you said, right?
Yeah.
Okay, so that's a good start. And as you kind of look at this, you kind of think, oh, okay, well, there's a P. We probably need to solve for P. And I'm okay with you having that as your first step. But even better, I want you to have that kind of that intuition behind. So what is it? Why are we solving for P? What is P?
The optimal amount we want to pay him.
Okay, and how do we, is it the actual optimal amount?
It's just what's like beneficial for us, regardless of what he does.
Okay. So what's the answer again, you guys? I'll skip the, well, I can just show the two steps here. We're going to take the 26,000 P equals the 42,000 P minus 1,000. And out from that, we get the optimal percent of, what was it, 6.25? Okay, so explaining in kind of real terms, what should the employer offer Ron? 6.25?
Wouldn't it be, but wouldn't it be like the kind of almost like break-even percent for the incentive for him to work harder? Like if it's any less than that, he's not going to want to work hard. He'll be lazy.
That's right.
And if it's 6.25 or a little more, then a lot more incentive.
Right. And exactly 6.25 does what? Like if they charge exactly 2.5 and Ron gets out his calculator and math, he's indifferent between those two states, right? Now, what would the employer really want to do then? 6.26 would be the economist mathematical answer of have it slightly ahead. Maybe it's 6.5%, maybe it's 7%, but something higher than 6.25, right? So the correct answer here of what we'd want to charge for a percent would be something greater than 6.25, a little bit greater, whatever that little bit is, and then of course we'd get into the real world and there'd be non-calculable aspects that we take into account of what it would take. Does Ron have kids? Do we have to bump up his percent to really induce him? You know, whatever.
Well, I was just going to say, isn't that piece based on the expected value of both outcomes of it? It's like more, that's the 6.25% of the expected value of profit.
Yes.
But realistically, if Ron works hard, he's thinking that it looks like they're going to be a 50% or a $50,000 profit. So the 6.25 is significantly more than 1,000. So it should still kind of work.
Okay, this model, the model assumes we have a rational agent,
Right.
and Ron makes these calculations.
Right.
The economist says that people in general make these gut transactions, and our mathematics approximates that. Behavioral economics teaches us that, well, maybe this rational paradigm's not quite right. There might be some human biases that would drift you one way or the other. I think that's a little bit of what you're bringing up, maybe, John, is that we might be optimistic that this is the number we kind of hone in on, and we tend to discount the bad and we favor the good or something going into it. That would be kind of a behavioral economics argument back to that. And then we can go back and look at data on how people actually process this stuff. Okay, so, but I guess the important part of calculating this problem is really understanding that to solve for that tipping point where it induces, from a behavioral standpoint, from the purpose of this chapter of the principal agent problem, in order to align incentives so that we mitigate moral hazard, we'd want to have a cut of the profits that would be greater than this to get Ron working hard. We'd need to have that, at least that amount. Okay? Any other last comments or questions there? Okay, so let's look at this last one then. Got a little insurance problem. So you own a house, $400,000, that's located on the river. If the river floods moderately, the house will be completely destroyed. This happens about once every 50 years. If you build a seawall, the river will have to flood very heavily to destroy your house, which happens about once every 200 years. What would be the annual premium for an insurance policy that offers full insurance? So let's just stop at that. Then we're going to get into a partial insurance. But let's try to bite off full insurance. Those of you who have worked a couple insurance problems or from the chapter, what's the idea of full insurance?
It replaces the value of the payout.
Yeah, it'll pay out $400,000, right? Okay, so go ahead, work on that one. See what you come up with. It's an expected value type of thing. And the question is, what will be the annual premium for a policy that offers full insurance? think that's right. Oh, let me grab my key. Yeah, that's right. That's right. You did the combination with the previous one after that.
Yeah.
So it's kind of helpful to think of yourself being an insurance company, and what's the probability of me having to shell out $400 grand? So pretend you're the insurance company. What is the chance, without a seawall, for starters, there's kind of two cases, but without the seawall, it was a 1 in 50 shot, right?
It just didn't say that.
What's that?
It didn't say that it was the walls outside.
Oh.
It just says.
Yeah, you're right, it doesn't. I guess the second, that maybe I was, I think might ask it later in the question here, with and without a seawall. Do the different policies provide incentive to be safer? Yeah. With and without, yeah, but it says it with partial, so I think you're still right, Chelsea. It doesn't technically ask for that. Oh, except these are two different events. So that is your answer. Without a sequel, that's your answer with a sequel. Right? So there's no connection. Yep. Good. Okay, so got the expected loss. This is without seawall. $100,000 loss with a 2% chance of a loss, 1 out of 50 equals the 8,000. So I think everybody got there with seawall. Still have a $400,000 loss, but we drop down to 0.005, a 0.5%, giving us an expected loss of 2,000. Now, let's just pause for a moment to digest this a second. The 8,000, how does the insurance company make money?
I think that $8,000 is putting it into investment one way or the other that pays interest every year.
From who? Well, that's part of it. That's not exactly how they make money, though. I mean, just you could somebody add on to what John's saying. I mean, what you? Go ahead.
I'm thinking maybe not every single person taking insurance is going to have their house.
Good. So that's the part I wanted to not forget, is that we're collecting 8,000 from a number of people, right? So if we collect from a large enough sample of people, we need that sample, by the way, to be randomly distributed of some people who will have a claim and who won't have a claim. Sometimes insurance companies have gotten screwed because their whole population is right on the Virginia Beach, and Virginia Beach gets wiped out, and we have everybody losing. Then that can kind of be harmful. So we kind of have to distribute it out that each individual person has this equal probability of that negative event occurring. So that's just one thing to keep in mind on how they make money with it. But you're right, we paid 8,000. Maybe we take 8,000 divided by 12, and that's our monthly premium. Okay, so partial insurance. What do we do to adjust for a 75% coverage? Okay, knock your costs down. So, what do you mean, Chelsea?
75% of your homeowner's worth.
Okay. And then who are you calculating for? The company or the home, or for the homeowner?
Oh, I didn't.
That's okay. I mean, I just from what you said there, I wasn't sure. So, without the seawall, our expected loss is how much for the insurance company?
6,000.
6,000. Okay, and how'd you calculate that? What's their risk of loss?
Well, you take the 75% of 400,000, which is 300,000.
Okay, good. So that's our first step here, is that the insurance company is only going to lose 300,000 in this event, right? So they have a 2% chance of losing 300,000. 75% of the premium. Okay? And so they get a $6,000 expected loss. And then with the seawall, we've got the 300,000 times the lower percent gives us our $1,500 expected loss. So, last part of the question.
How would that look different for the person?
Right, that's the last step I want you to do, is calculate what's the expected loss for the person now with partial insurance. So that one's kind of a combination. So this is what it looks like for the insurance company. They're more than happy to provide you insurance of at a premium of $6,000. What does it look like for the homeowner? What's the chance that the homeowner now with partial insurance is going to have to pay $100,000? That's kind of the first part, at least in my mind, in processing it. What's the chance that the homeowner is going to say, "Crap, I lost. I got to shell out $100,000 because I didn't carry full insurance." Yeah, it's that same percent. That's right. So the homeowner's taking on the risk. You guys, you all right with that? Is this it? The homeowner's taking on a $100,000 loss. So if they get the policy.
Right, it's 25%.
Oh, okay, I got you. Yeah. Yep. I'm tracking on that. Got you. Yep. And so what is their total loss though? So you got a couple things to combine together. Total expected loss for the homeowner. What did you get? Well, it's part of the answer. So what did you get? The same thing? The 2,000? So put the two things together. What do they need to do to have? Yeah. Right. Well, one's with certainty.
I'm just saying, like, I don't know.
But yeah, what's the cost? Well, in insurance terms or in these type of problems, if you've got expected loss, but it has a chance of 0 of occurring or 1, it's one of the endpoints, you can still run it into the expected loss formula. So you just know that you're gonna lose 6,000 with certainty by getting the partial insurance. You're gonna pay the company 6 to get rid of that risk, and then you're gonna take the other one. So what's your expected cost or expected loss?
What would be the fixed cost of the wall? The original?
I don't think that was talking
No,
about
we
it.
just ignored that. Yeah. But that's exactly how the decision would come down, is whether the wall's worth it or not, and whatever that cost of that wall would be.
So it would be just going to.
So did you guys combine those two things?
Yeah.
Okay. And you get the same thing, which is kind of an interesting result that I want to talk about. How you did it. Okay, so you got this, and then now if you buy the policy, you're going to for sure spend 6 on the partial policy, and then you're going to run the risk of that. So your expected loss is still 8,000, just like it was with the full policy. Okay. All right, so I'm just going to do it, I think, with, I'll just do it with the CMOL. Or without the CMOL. So this is to the consumer. I could have notated this a little better, but so we've got the $6,000 premium that we know for sure that came through. We got a 100% chance of quote unquote loss or cost there, plus now you guys correctly identified a 2% chance of getting stuck with the $100,000, which gives us our.
So that 6,000 is kind of like a fixed cost, like you're gonna pay that no matter what
Right.
happens.
Yep. And so the interesting result that we get is 8,000. So, expected loss 8,000, expected loss 8,000. Am I indifferent between these two policies? Flip a coin, I'll take either one. What's that, Chelsea?
About like how much, like what Katie brought up about how much the wall costs and everything that's gonna throw in.
Okay.
Whether you wanna make the decision or not.
Okay, now you're bringing up wall versus no wall, which is true, but I'm bringing up without a wall. Without a wall, 8,000 full insurance.
Oh, but
Without a wall, 8,000. So yeah, I'm just kind of want to push you on. Does the homeowner not care then? I'll buy this, or I'll buy this. Expected value is the same. Flip a coin. I'll take either one.
Why did we add the 6,000 to the 2,000? Because if we calculated 6,000 for the company, I'm just confused to why we combined it with the consumers.
So
Loss, why did we combine it to loss?
the consumer's going to pay that as a premium to the company to get rid of the risk of the 300,000. So their cost, expected loss now is.
So then why did we write it as a loss for the company? Why did we classify it as a
That's more
loss?
the expected value of the premium.
Okay.
Yeah, up here it's expected loss for the insurance company. I didn't use very nice notation. I could have
What
been a
do you
little more
mean?
careful. So the insurance company says, if I only have to pay you out 75%, there's a 2% chance of that event happening. My expected loss as the insurance company is 6. So Mr. and Mrs. Homeowner, if I charge you a $6,000 premium, I'm okay with that. That's a fair bet. Okay? So now Mr. and Mrs. Homeowner is down here, and what I'm asking is, what does their situation look like now under partial insurance? And their expected loss is the same under full insurance. They've got a $6,000 cost of the premium they're paying to the company. And now they're rolling the dice on whether or not they're going to get hit with another $100,000 expense, giving them a total expected loss with a for sure component and an uncertain component of 8,000. Is everybody okay with that? Because now it's back to the big question here of full insurance, the company pays it for sure, and I'm covered, I pay 8,000, or this one down here has expected loss of 8,000. Is the homeowner truly indifferent between the two? It's like, oh, I don't care, either one. Which one do you think the homeowner's going to pick?
75. Wow, that's-
This one? Why do you say that, Kate?
Well,
Because it's a 1 in a 50 chance.
yeah. they're saving $2,000.
Yeah, $2,000 combined.
Okay. So you're seeing it that way, okay? Everybody agree with that? Colby, you don't?
I would take the insurance because you don't know when that one in those 50 years is going to happen. It could happen like in 5 years, or it could happen way down the road.
Okay. So you can see kind of those two things, right?
Oh wait, are you saying that's an annual? That would be
Yeah, this is annual.
That would be an annual loss. That 2,000 would be an annual loss. That would
So it's a chance.
It's the expected before the year begins. Now, that's kind of where I'm going with this, is after the year ends, now we're back to what Kate's pointing out, and there's no event, there's no flood, then you spent 6,000, right? Because this wasn't realized. This one kind of disappeared. Somebody who took full insurance spent 8,000. So that's absolutely true.
Might depend on how risk averse.
Good. That's the word I was looking for. Thank you, Chelsea. That's probably worth an extra credit point. Risk aversion. All right. So we have 3 categories when it comes to this type of stuff: risk averse, risk neutral, and risk loving. Risk loving is kind of the weirdos who would actually prefer to take on risk, even if it has a lower expected value. But risk aversion is what people are normally wired. Maybe Colby was thinking that's the way people are wired, is that they'd probably, if they did all these calculations, they'd take the one where they're covered for sure, rather than roll the dice.
So it's basically just how much risk you're willing to take on.
And whether you're willing to pay. So risk averse people are willing to pay a premium. They're willing to pay more to avoid the risk. They're willing to pay a risk premium. And then I think in maybe the intermediate class we did those little graphs with the utility function and it's diminishing. Anyway, but I just wanted to bring that up here. When you do the cold hard calculation, it comes up like this. But if you're risk averse, we probably lean towards you would lean towards the for sure deal of 8. If you're risk neutral, you'd be kind of the coin flipper situation. You'd say, oh, well, this had the exact same expected loss value. I don't care. I'm indifferent between the two. I'm risk neutral. Okay. Yeah. Yeah.
Gosh.
Yeah, no kidding. That's a good point. All right. So, that is it for, not quite the day, no. So this next chapter kind of brings in the concepts that we talked about in Chapter 8 with adverse selection and moral hazard with the financial crisis. And your text goes into multiple crises. We talk about the big one, of course, that recently just happened, and then looks at some bits and pieces of the Great Depression and other things that have happened around the globe to try to see if we can gather some facts about some patterns that arise with these crises. Two little things we're going to do. Yeah, this one should go. Let's start with this one. So read that to yourself. It's right out of your textbook. It's one of those little box exercises. Collateralized debt obligations, CDOs.
Hey, today's Groundhog Day.
Today is Groundhog Day, yes.
Did it see shadow?
I don't know.
Or have it even
It has
checked out
for
yet?
Snapchat.
He did another, whatever, the longer one. The shadow was out because that snowstorm was going through.
Why are you rolling around phone?
That's true, yeah. That's
Because it's American.
His name's Phil, too.
Phil.
Fun fact.
Phil.
Punxsutawney.
Punxsutawney Phil, yeah. I think Punxsutawney is what is it,
The
Michigan?
name of the town.
Pennsylvania.
Pennsylvania.
It's Groundhog Day.
John,
Enjoy
get
it.
in the spirit of the holiday.
I actually think
All right, did you guys read this thing already? Somehow we got on Groundhog Day. Read your little blurb there. Okay, so what do these CDOs sound like? Credit.
Using the term.
So I lamented about whether to do this once again. Definitely going to show part of it. So my question to you guys, though, I decided it would just be best to just see what you guys thought, is it's an 11-minute video, the crisis of credit that we
The other day, came to the world and you.
that we've seen before. As we start to put on more and more layers onto our knowledge, I think it's helpful to go back to this. But I was thinking about jumping about partway where they talk about the CDOs in the video. Do you guys want to watch the whole thing? It's 11 minutes, or it'll be about 6 to 7 minutes. I'm not shaving that much off, but about 6 minutes if we do that. How many people would like to see the whole thing? How many people would like to just skip to the, okay, I see, looks like majority. How many people want to skip to the CDOs? All right,
We're all Lego.
I'm going to take the majority. I've watched it 100 times and I still
The
like it.
crisis of credit, visualized. What is the credit crisis? It's a worldwide financial fiasco involving terms you've probably heard, like subprime mortgages, collateralized debt obligations, frozen credit markets, and credit default swaps. Who's affected? Everyone. How did it happen? Here's how. The credit crisis brings two groups of people together, homeowners and investors. Homeowners represent their mortgages, and investors represent their money. These mortgages represent houses, and this money represents large institutions like pension funds, insurance companies, sovereign funds, mutual funds, etc. These groups are brought together through the financial system, a bunch of banks and brokers commonly known as Wall Street. While it may not seem like it, these banks on Wall Street are closely connected to these houses on Main Street. To understand how, let's start at the beginning. Years ago, the investors are sitting on their pile of money, looking for a good investment to turn into more money. Traditionally, they go to the U.S. Federal Reserve, where they buy treasury bills, believed to be the safest investment. But in the wake of the dot-com bust on September 11th, Federal Reserve Chairman Alan Greenspan lowers interest rates to only 1% to keep the economy strong. 1% is a very low return on investment, so the investors say, no thanks. On the flip side, this means banks on Wall Street can borrow from the Fed for only 1%. Add to that general surpluses from Japan, China, and the Middle East, and there's an abundance of cheap credit. This makes borrowing money easy for banks and causes them to go crazy with leverage. Leverage is borrowing money to amplify the outcome of a deal. Here's how it works. In a normal deal, someone with $10,000 buys a box for $10,000. He then sells it to someone else for $11,000. For a $1,000 profit, a good deal. But using leveraged, someone with $10,000 would go borrow $990,000 more dollars, giving him $1 million in hand. Then he goes and buys 100 boxes with his $1 million and sells them to someone else for $1,100,000. Then he pays back his $990,000 plus $10,000 in interest. And after his initial $10,000, he's left with a $90,000 profit versus the other guy's $1,000. Leverage turns good deals into great deals. This is a major way banks make their money. So Wall Street takes out a ton of credit, makes great deals, and grows tremendously rich, and then pays it back. The investors see this and want a piece of the action, and this gives Wall Street an idea. They can connect the investors to the homeowners through mortgages. Here's how it works. A family wants a house, so they save for a down payment and contact a mortgage broker. The mortgage broker connects the family to a lender who gives them a mortgage. The broker makes a nice commission. The family buys a house, becomes homeowners. This is great for them because housing prices have been rising practically forever. Everything works out nicely. One day, the lender gets a call from an investment banker who wants to buy the mortgage. The lender sells it to him for a very nice fee. The investment banker then borrows millions of dollars and buys thousands more mortgages and puts them into a nice little box. This means that every month he gets the payments from the homeowners of all the mortgages in the box. Then he sicks his banker wizards on it to work their financial magic, which is basically cutting it into 3 slices: safe, okay, and risky. They pack the slices back up in the box and call it a collateralized debt obligation, or CDO. A CDO works like 3 cascading trays. As money comes in, the top tray fills first, then spills over into the middle, and whatever is left into the bottom. The money comes from homeowners paying off their mortgages. If some owners don't pay and default on their mortgage, less money comes in, and the bottom tray may not get filled. This makes the bottom tray riskier, and the top tray safer. To compensate for the higher risk, the bottom tray receives a higher rate of return, while the top receives a lower, but still nice return. To make the top even safer, banks will insure it for a small fee called a credit default swap. The banks do all of this work so that credit rating agencies will stamp the top slice as a safe AAA rated investment, the highest, safest rating there is. The OK slice is BBB, still pretty good, and they don't bother to rate the risky slice. Because of the AAA rating, the investment banker can sell the safe slice to the investors who only want safe investments. He sells the OK slice to other bankers, and the risky slices to hedge funds and other risk takers. The investment banker makes millions. He then repays his loans. Finally, the investors have found a good investment for their money, much better than the 1% treasury bills. They're so pleased they want more CDO slices. So the investment banker calls up the lender, wanting more mortgages. The lender calls up the broker for more homeowners, but the broker can't find anyone. Everyone that qualifies for a mortgage already has one, but they have an idea. When homeowners default on their mortgage, the lender gets the house, and houses are always increasing in value. Since they're covered if the homeowners default, lenders can start adding risk to new mortgages, not requiring down payments, no proof of income, no documents at all. And that's exactly what they did. So instead of lending to responsible homeowners, called prime mortgages, they started to get some that were, well, less responsible. These are subprime mortgages. This is the turning point. So, just like always, the mortgage broker connects the family with a lender and a mortgage, making his commission. The family buys a big house. The lender sells the mortgage to the investment banker, who turns it into a CDO and sells slices to the investors and others. This actually works out nicely for everyone and makes them all rich. No one was worried because as soon as they sold the mortgage to the next guy, it was his problem. If the homeowners were to default, they didn't care. They were selling off their risk to the next guy and making millions, like playing hot potato with a time bomb. Not surprisingly, the homeowners default on their mortgage, which at this moment is owned by the banker. This means he forecloses and one of his monthly payments turns into a house. No big deal. He puts it up for sale. But more and more of his monthly payments turn into houses. Now there are so many houses for sale on the market, creating more supply than there is demand, and housing prices aren't rising anymore. In fact, they plummet. This creates an interesting problem for homeowners still paying their mortgages. As all the houses in their neighborhood go up for sale, the value of their house goes down. And they start to wonder why they're paying back their $300,000 mortgage when the house is now worth only $90,000. They decide that it doesn't make sense to continue paying, even though they can afford to, and they walk away from their house. Default rates sweep the
You guys
country
think
and
moral
prices
hazard,
fall.
adverse selection,
Now the
principal
investment
agent
banker is
problem as you're
basically
going
holding
through
a
this?
box full of worthless houses. He calls up his buddy, the investor, to sell his CDO, but the investor isn't stupid and says, no thanks. He knows that the stream of money isn't even a dribble anymore. The banker tries to sell to everyone, but nobody wants to buy his bond. He's freaking out because he borrowed millions, sometimes billions of dollars to buy this bond, and he can't pay it back. Whatever he tries, he can't get rid of it. But he's not the only one. The investors have already bought thousands of these bonds. The lender calls up trying to sell his mortgage, but the banker won't buy it, and the broker is out of work. The whole financial system is frozen, and things get dark. Everybody starts going bankrupt. But that's not all. The investor calls up the homeowner and tells him that his investments are worthless. And you can begin to see how the crisis flows in a cycle. Welcome to the crisis of credit.
All right, so what we're going to do the rest of the week, the next 2 meetings, is go through some discussions and readings and video and kind of go back and forth to kind of hopefully round out the information that's in the chapter and complement it. So that's my plan. We'll see you guys on Wednesday.